name is Manirajan. In this class, deep learning using Pythons. Okay, this is conducted by the Mu Technology. We talked about these sections. Uh, Mu deep learning in Scratch. Okay, just see the two numbers number sequence. One is the input, the another one is the output. See just the input is the number has 0, 8, 15, 22 up to 1. At the same time you see the outputs also, the 32, 46.4, 59, 71.6 up to add on. Or you guess any relationship between the inputs and the outputs? It means I given the 0 no? I get the output is 32. I given 8, I get the corresponding output is 46.4, like that. You have find out any relationship between the inputs and the outputs. Okay, you take your time, just calculate this. You find out any patterns following this number sequence. Okay, or you find out any patterns. Okay, you find out the pattern, and now just find out this values corresponding outputs. My problem statement is I have two number sequence, I have corresponding outputs also. Now I getting one new number in inputs, I want to get corresponding output in that particular number. My input number is 38, I want the corresponding output is I need. Okay, okay, or you find out 100.4 is not is correct, is absolutely correct. How its number is came here? Anyone have any ideas? No, right? Okay, we see how it's coming. Okay, this is the very simple problem, guys. This is Celsius to Fahrenheit converter calculations. You see in your science books uh, up to 8th or 9th. Some people are forgot this those things. Some people are remember still now. Okay, that's fine. Or you forgot now? Also, you just remember those things. Celsius to Fahrenheit converter calculations. Okay, how it's happen? How it's happen? You have some Celsius value in temperature. The same Celsius value have another one format. Another one unit is Fahrenheit. How to convert this in programmatic area? We have a lot of ways. In this class we discuss about how to do in deep learning. Okay, and the corresponding output is number, right? You want to predict some numbers. Okay, that is the regression problem. What we do now, you give some input values for the temperature in Celsius. The I want to predict the corresponding temperature value in Fahrenheit value, Fahrenheit units. Okay, how you do in deep learning? I given input data to the neural network, the neural network predict my output value, okay, in Fahrenheit. How it's happened? My training neural network is have some layer set of layers, right? Some neurons also. I create two different type of neural networks. One is only one layer, one neurons. Another one is multiple layer, multiple neurons. Let's see how it's work. Okay, Celsius to Fahrenheit prediction flow. What is the flow? You have first one is understand your data. Okay, second thing create your model. Third thing compile the model. Fourth thing train the model. Fifth one is the visualize your model. Sixth one is the predict your model. Okay, first one understand your data. Not only deep learning, you take any data related problems. First thing is you understand your data. How many columns in your data sets, how many rows, how many missing values the data set have is balanced or imbalanced, like that. Okay, how it's work in our, what is the nature of the data. So you understand your data first. Not only deep learning, you take any data related problems. Second thing, the second every 2 to 6 points, right? This everything is undercover the neural network. Okay, first thing is the creating the model. What is the creating the model means? You have defined your layers, how many layers in your neural network, how many neurons you want. Okay, what is the activation functions, those things you define the creating the model. Compile the model. Once you finish the creating the model, after you come to the compile the model. In this part you will cover two things. One is the loss function, second one is the optimizer. What is the loss, what is the optimizer? Your model is learn something, right? Your model is learning some temperature value to predict some Fahrenheit values. Okay, the first time your model is not learned properly. Okay, is learn some, something is wrong, something is different. Okay, um, you you want to you want to calculate the loss also. Okay, how do your model is learned? Okay, that is the loss. You want to reduce the your loss, that is the optimizer. How do you reduce your uh, loss na? Used to optimizer. In the later class we will see very briefly what is loss, what is optimizer, what is other things, other parameters also. Okay, once you created the model and compile the model, after you do in training the model. Okay, we will use the fit method using the train. Okay, numpy fit method using the train. The fit method map the input and corresponding output the values using fit method, numpy fit method in training period. After the training is completed, visualize your model. Your model is learn something, right? Everything is done, the training process also is done. Your model is learn something, but you don't know your model is how learned, is learning is correct or not, like that. So you visualize the model, you getting some ideas, your model is how it's learned. Finally you predict the model. Your model is completely ready now, you just given some inputs and predict your uh, corresponding outputs. Okay, just understand the data. Just you see input data and our output data. You follow some pattern. We already discussed about the patterns, right? The input and outputs is following some patterns. Okay, pattern it's not a, it's nothing but is a one mathematical equation, some logics. Okay, it's nothing but what is the mathematical equation in these problems? F equal to c into 1.8 plus 32. You already see in this formula in your science book or some other web articles somewhere. Okay, the same mathematical equations. uh, I already know this equation, so I put here. Okay, you just, what is the F means? F is a Fahrenheit. What is C means? C is a Celsius. Okay, it's a very basic simple mathematical formula, guys. You already about this. Okay, what is C? C is a Celsius temperature value in Celsius. Okay, 0, 8, 15, 22, 38. This everything is a input value Celsius. And what is Fahrenheit now? The corresponding output. Okay, 32, 46.4, 59, 71.6. This everything is a Fahrenheit value. In this problem is a output value also. This is. Now I want to predict 0 corresponding output value. 0 degree Celsius corresponding output value, corresponding Fahrenheit value. Okay, how I do this? I just put 0 in the mathematical equation. I replace c to 0. Okay, 0 into 1.8 plus 32. Okay, what has happened now? 0 into 1.8 is equal to 0 plus 32. 0 plus 32 is equal to 32 only. Now I getting f value equal to 32. This is the corresponding 0 degree Celsius, corresponding Fahrenheit value is 32. Like that only you calculate, put 8 in this c place. You replace the c place in 8, 15, 22. You getting the those values. You just check it manually or you do some calculation using calculator or programmatically in your own time. Now we are go to move on. Okay, how I do in this problem in programmatically? I have one solution, traditional software development. Okay, what is this? traditional software development. I have a input. I already know algorithm also. I have read the one function to produce the outputs. Okay, I given to the input, apply the some logics, I produce some results. Right. This is the very basic traditional methods. How? This is my mathematical equation already see, right? This is the logic also in my programs. You want to write some programmatically na, okay, I write one of the programmatically way in Python. Okay, def function, um, the argument is c, அதுக்கப்புறம் f equal to c into 1.8 plus 32, written is f. This is very basic Python program. Right, def is equal to keyword, function is a function name, c is equal to argument, f is equal to c into 1.8 plus 32 is a logic. My this function logic, return value is f. Okay, what is okay, we explain this function in briefly. In this function c is a input. Okay, my second line is a one equation, right? That is the algorithm or logics. I written f. F equal to foreign head values is a output, the corresponding output. My input value I passing some values na 0, 8, 15, 22 na. The 0 is replace the c. After applying some logic, I have getting some return values 32, like that. In other hand, I have machine learnings. Okay, in this machine learning I have inputs, I have outputs, but I don't have algorithm. I don't know algorithm. In starting period I give some times, right? You calculate some relationship between the input and outputs, but most of the people don't know the relations between the outputs and output and inputs relationships. Why you don't know? I given some times also, but you don't, but you could not calculate those things. Is little bit tough, but this is very simple mathematical equations. Okay, this is a very simple thing, but you just assume you want to predict tomorrow weather. Okay, how you do? Okay, you take an last 50 to 100 year data and find some relationship between those data. After you applying some logics, after you predict tomorrow is weather's. Okay, right? This is a very difficult task. We can't do these things. Okay, we do the temperature things also, but we can't do the weather predictions. Okay, that time we are using the machine learning. How it's do? How it's happen now? We taking pair of inputs and output data. Okay, we passing to the neural network or machine learning algorithms. The algorithm find out the patterns. Okay, the algorithm figure out the patterns and the relationships. In this case the same thing. I have a input data 0, 8, 15, 22, but I don't know the algorithm, I don't know the logics. Now I want to corresponding output, the input corresponding output. Now I use the neural network. Okay, I passing all information to the neural network. The neural network is learn something, after it predicts something. What has happened now? This is my input values and outputs values I given to the neural network. The neural network is learn this input value and output value again to again. You have end of the day, end of the process, the neural network have some ideas about my data. Now I given something now, the neural network predicts some values, our previous knowledge. Coding part. Okay, let's see how we do in coding in this everything. Okay, first one is creating a model. We already see the understand our data. Now we see creating the model. The yellow color thing is coding part. see just layer 1 equal to tf dot keras dot layers dot dense in the brackets inside unit 1 and unit input shape is 1. What is layer 1? Okay, layer 1 is called um, the layer names. Okay, I just initialize layer 1. Okay, then the layer name is I just initialize the layer 1. You want anything, you want put anything. Okay, L1 layer name is 1. You want put any names. Okay, our names also is fine. How it's create now, tf dot keras dot layers dot dense. We already have any idea about tf and keras? Just live about the layers and dense. You have any idea about tf and keras? Okay, I will explain. TF is equal to open source machine learning platform. Okay, TF is the one of the framework. Okay, it's a machine learning framework. It's a very famous framework. I think two framework is very familiar. One is a PyTorch, another one is TF. TF is created by the Google researching community. It's a very one of the very famous framework in machine learnings. Keras is high level API running on TF TensorFlow. Okay, that's it. Layer is a layer is a built-in. What is this? Okay, layer is a fundamental building blocks in layer. How to define the layers? How many layers you want? Those things are define the layer functions. Dense is a very basic thing, guys. Uh, Add on some inputs and add on some bias, so multiply with some weights and add on some bias. Some basic dot product is happening in dense layer. Okay, in this dense layer I have mentioned two parameters. Okay, two arguments, right? One is input shape, another one is unit. What is the input shape? Okay, in this problem I already saw the problem statement, right? My input is 0, 8, 15, 22, like that. That only one row, right? Only one number sequence. It's a one dimensional array, so I put 1. Okay, your problem statement is based on you given the numbers. I specify the my input shapes. Unit, what is a unit? I want to specify how many neurons in my layers, my first layers. Okay, I want only one neurons in my first layer. Okay, I put 1. So you want so many neurons and you just put another numbers 5, 10, like that. Okay, next sequential. Okay, what is a sequential? Sequential is not a layer. Sequential is a model. Okay, sequential is a one of the model. You want to create some model in TensorFlow now. One is the functional API, another one is a sequential. The sequential, what is the do now? The assemble the layers. In this problem, we have only one layer, right? But you go to the real time scenario, you have lot of layers. Okay, layer 1, layer 2, layer 3, dropout layer, lot of layers. Okay, you want to assemble the every layer in one block, right? That is sequential. Sequential model is defined list of layers and arguments. Once you finish the model creation, after you come to model compile. Okay, in this part we will cover two things. One is loss function, another one is optimizer. What is loss function? Your model is predict something. Okay, your model is predict something. You give some inputs. The input is process some operations, multiply with weights and add on some bias. You getting some values, right? The value um, is first time is not predict properly, I think. Okay, you want to desire some kind of some modification outputs. Okay, that time you want to calculate your prediction value and actual value. You calculate the difference. Okay, that is loss function. Optimizer, you want to calculate loss, you want to reduce the loss. Okay, so you use to optimizer, you reduce the loss. In this function, I used a mean square error loss function, and optimizer is Adam. Why Adam is? Adam is the very standard and stable optimizer, so I use Adam. After that, I using one parameter 0.1. What is the 0.1? Why I use this uh, here? See, the 0.1 is learning rate. You have any idea about learning rate or gradient descent? Okay, no issues. Uh, just you assume the learning rate is very small value. It's the learning rate is based on optimize your loss. Okay, you just assume these things only. You just maintain your these things. Learning rate is a very small value. The based on learning rate, your optimizer optimize the loss. Training the model. Okay, you finish the model creation and finish the model compilation. After you come to train the model. In the train the model, we will use fit functions. Okay, numpy fit function. Okay, in the fit function, using mapping the input value and the corresponding outputs value, map to the input value and outputs value. I passing three arguments inside the fit function. One is the first one is input, the second one is desired output, the third one is epochs. What does epochs means? I want to teach something. Okay, in the neural network, learn only one time is not enough. Okay, is learning. I teaching again to again. I iterate this process. Okay, 5 times, 10 times, 100 times, 500 times, like that. So epochs is how many times iterate this process. Okay, should be run this process. That's it, guys. Visualize the model. Okay, last time we saw the fit function, right? The fit method is return one object, that is history object. Okay, the fit method is return history object. That history object you want to plot now, you have some ideas about your loss. Okay, your model is the loss of your model go down after each training epochs. uh, the every training epochs your model learns something. Okay, you optimize some weights and biases, so your model improve every hydration. you want to see you want to see now, you just plot the history method, history object. I using um, matplotlib to visualize this model. plt dot plot of history in loss. This is the code of code and plot the model. You see very clearly my errors is starting for 7,000 something, but after or 100 epochs my errors is come to nearly 1000. Okay, the errors is the epochs is increased increasing. Sorry, my epochs is increasing, my errors also come to nearly zero. Okay, so my model is now it's good. After predict the model, a model has been trained. Okay, the overall my model has been trained, is learn the some relationship between the Celsius and Fahrenheit. I if I give some value now, you predict something. How? The model already trained, already calculating, sorry, already learned the relationship between the Celsius and Fahrenheit. I given some input, the calculating, the input have some operation, some mathematical operation, they calculating something. Okay, how now is previous knowledge, previous Celsius knowledge is given some outputs. Okay, this is my overall code. I define the layer 1 is equal to layer name tf dot keras dot layer dot dense. Inside unit equal to 1, input shape equal to 1. tf is equal to TensorFlow is a machine learning platform. Machine learning platform. Keras is high level API, runs on TensorFlow, runs top on TensorFlow. Layer is a basic building function. Dense equal to some dot product operations. Do some dot product operations. Second thing, sequential. I initialize the every layer in sequential model after I compile the model. I using loss function is called loss function is mean square error. Optimizer is Adam. I initialize learning rate also 0.1. Why? How my loss is my optimizer is work fast or slow based on learning rate. History is equal to model dot fit. Inside the fit method I put three parameters. One is input Celsius, another one is output Fahrenheit, another one is epochs equal to 100. I want to 100 time headed this process, this training process, so I put 1000. If you want other epoch size in 100, 1000, 2000, in your in your choice. The deep learning is everything is trials and error, you do your choice. Finally I print the some values. I predict some values. Okay, second thing, the last model we have only one layer, one neurons. Okay, we given one input, the process only one layer, only one neurons. In this case we use two layers. The first layer have five neurons. Okay, five neurons. The second layers have only one layer. Sorry, second layer I have only one neurons, that is output neurons. The same thing. Okay, uh, I put the name of layer name is a1 layer 11 tf dot keras dot layer dot dense unit equal to 5. Last time I put 1. Why means I want only one neurons. This time I want 5 neurons, so I put 5. Input chip is same, the one. Second layer is I put layer 1 2 is equal to tf dot keras dot layer dot dense unit equal to 1. Okay, I want only one neurons in second layer. Don't put again to again the input chip another layers. The input chip is only initialize the first layers only. The first you initialize the first layer in input chip, now it's enough. Okay, don't uh, initialize every layer. Second, I initialize the every layer in a sequential model. I already told, right? In your real case you have lot of layers, you initialize to the sequential model. Same thing. This is the overall code. Layer 1 is equal to dot keras dot layer dense unit equal to 5, input shape is 1. Okay, the layer 2 is equal to tf dot keras layer dot dense unit equal to 1. This is my second layer, and I initialize the model 2 is equal to tf dot keras dot sequential layer 1 1 comma layer 1 2, and we go on compile. Okay, I use loss equal to mean square error, the same thing. Optimizer is Adam, and I fit the model. Finally I predict some outputs.